Lesson 932, Hypothesis Tests for Paired Samples. In a previous lesson, we tested claims about a population mean. In this lesson, we learn how to test a claim about a population mean of paired differences. We will see that the process for testing claims about a population mean of paired differences is the same as the process for testing claims about a population mean. So the previous lesson, 931, we did hypothesis tests for a population mean. This is going to be the exact same process, except that we will just have to find the differences between two values first. So let's see how that goes. Assessing a psychological treatment. Psychologists often argue over the best way to help people with anxiety. Two possible treatments are counseling sessions and pharmaceutical treatments, in other words, medicine that helps to reduce anxiety. Suppose that a team of psychologists has recommended that people who experience anxiety attacks should receive regular counseling. The psychologists claim that the counseling sessions provide a therapeutic or healing experience. The psychologists promote this type of therapy rather than pharmaceutical treatments. To test the effectiveness of counseling, a researcher randomly selects 6 people who experience anxiety attacks. These 6 people are interested in the counseling treatment. The researcher gives each person an anxiety test before and after the person has a counseling session with a therapist. Higher scores on the test indicate a higher level of anxiety in the person taking the test. The test scores of the 6 people are shown in the table below. At the 5% level of significance, can we confirm that the counseling sessions reduce anxiety? Assume the population of test score differences is normally distributed. So first we have this data. In the first row we have person 1, 2, 3, 4, 5, 6. And then we have scores. The second row has the pre-counseling score on the anxiety test. And then the last row has the post-counseling score on the anxiety test. Step 1. Determine the hypotheses. Number 1 asks, are the data paired? Explain why you think they are or are not paired. In an earlier lesson, we saw that paired data meant that they were dependent. And we can say, yes, these are paired because each person has 2 scores. So we have paired data. Number 2, if counseling does not make a difference in anxiety levels, what should the mean of the differences in test scores be? So here we see this phrase that we've seen before, does not make a difference or no difference. So if there is no difference, that means that the difference would be 0 on average, which is giving us the inclination that the mean of the differences should be 0. So no difference, which means that the mean of differences in test scores is 0. Number 3, if counseling helps reduce anxiety and does make a difference, would we expect the difference to be positive or negative? So hint, the difference is the post-counseling score minus the pre-counseling score. So first of all, the difference that we're looking at is post-counseling score minus the pre-counseling score. If we go back to what was detailed in the study, at the very end of the third paragraph, it says higher scores on the test indicate a higher level of anxiety. So if we are taking the score after counseling and then subtracting the score before counseling was done, if the counseling is helping to reduce the anxiety, we would expect that the anxiety score on the anxiety test would be lower on the post-counseling score. So we would have a low score after counseling minus a higher score before counseling. If we take a small number and subtract a bigger number, we are going to get a negative. So that's the answer for number 3. So now let's put all of that together in number 4. Number 4 says state the null and alternative hypotheses. So again, we're still using the symbol mu for mean. In this case, we're thinking of it as the mean of differences. We have to use equality in the null hypothesis. And let's think of what we wrote in number 2. The mean of differences in test scores is 0, which means mu is equal to 0. And then for the alternative hypothesis, we just have to compare mu with 0. And here we can think of what it means to be a negative number. It means less than 0, which means the symbol for number 4 would be mu for the mean is less than 0. And then number 5, now that we have our hypotheses, is this a right, left, or two-tailed test? Since we have the less than symbol here, this is a left-tailed test. Step 2, collect the data. Number 6 asks, are the criteria for approximate normality met for the sampling distribution of means of sample differences? So do we have n greater than 30? No, because we only have 6 patients. Which means we would only have 6 differences in test scores. But if we go back to what was given to us, we did have an assumption. Assume the population of test score differences is normally distributed. So we do have that the population of test score differences is normally distributed. So since we at least have that, then we can say yes for number 6. Number 7, determine the following: the mean of the sample differences, the standard deviation of the sample differences, and the number of data pairs in the sample, n. So we already know how many pairs we have because there are 6 patients, so n is equal to 6. And to figure out the mean and standard deviation, we need the sample differences, which we haven't found yet. So if we go back to our table, it might actually be a little bit helpful if we just remember that we're taking our post-counseling score and subtracting our pre-counseling score. So we're going to make a new row at the bottom here that just has the post score minus the pre-counseling score. So for example, if I take for person number 1, the post-counseling score of 64 minus the pre-counseling score of 66, that's -2. For person number 2, I would take the post-counseling score of 65 and subtract the pre-counseling score of 71, and that's -6. So we're really just taking the numbers in the bottom row and subtracting the numbers in the second row. So for the third person, that would be 79 minus 80, which is -1. And then for person 4, 81 minus 78, which would be 3. Person 5, 81 minus 85 is -4. And then person 6, 91 minus 90 is 1. So the numbers that I'm actually using to find my mean and standard deviation, those are the results that we have here. So I'm going to make a list with these numbers in that list. So in your TI 83 or 84, you can say list 1 and then just have -2, -6, -1, 3, -4, and 1. And those are the 6 numbers in your list. So go ahead and take a couple minutes to fill out that list, and then you're going to use the one variable statistics like we've done in previous lessons to get the mean and the standard deviation. And what you should get for the mean is -1.5. We shouldn't be surprised that the negative is in the mean because more than half of those differences were negative. And then our standard deviation, which gets the symbol S, that's going to be 3.271. And then we already said that our number of data pairs, n, is 6. So then question 8. Is the mean of sample differences consistent with the alternative hypothesis? So, does the mean that we just got agree with the alternative hypothesis? So, is the sample mean less than 0? And we would say yes, because our sample mean, x bar equal to -1.5, it's negative, so it is less than 0. The secret word for this lesson is differences. Step 3. Assess the evidence. Number 9, calculate the test statistic for the observed mean of sample differences. This is just like lesson 931. T is equal to x bar minus mu divided by s over the square root of n. So our sample mean is -1.5. The population mean, mu, remember that comes from our null hypothesis, that's 0. And then we have to divide by the fraction that has our standard deviation, 3.271. And then we need to divide that by the square root of 6. And again, we need to be cautious with how we enter this into our calculator. -1.5 minus 0 is just -1.5. And then you can press the divide button, but you need to use parentheses here. 3.271 divided by the square root of 6. Because the fraction in the denominator, 3.271 divided by square root of 6, has to happen first. And then we are allowed to divide -1.5 by that. So entering it into our calculator just like that, this will give us -1.124. Number 10, sketch the t-distribution. Identify the position of the observed test statistic. Shade the area that represents the p-value. Again, we're going to have our horizontal axis, a normal distributive curve, something that looks similar to that because, again, the t-scores approach the normal distribution. Then we have our test statistic is on the left because it's negative. So TS equal to -1.124. And the area that we are shading is to the left because we have a left tail test. And that area represents our p-value. And then the way that we find our p-value, as we discussed in the previous lesson, the p-value, we can use the tCDF function. So second vars tCDF, we're going to enter the lower t-score and then the upper t-score and then our degrees of freedom. which means TCDF. Since we have a left tail test, the lower t-score is negative 1E99. The upper t-score is negative 1.124. And our degrees of freedom would be sample size 6 minus 1, which is 5. Remember, we can also use the t-test under the tests function with stats. Enter in your mean and standard deviation and your sample size, and you can get the same answer for the p-value. You should get approximately 0.156 as your p-value. So just like we saw in the previous lesson, now that we have our p-value, this is where we can start drawing conclusions. So first of all, number 12, how does the p-value compare to the significance level? Hint, is it greater than, less than, or equal to? So our significance level back at the beginning of this example, we were told that the significance level was 5%. So alpha is 5%, or 0.05. Our p-value is 0.156. That is greater than our alpha, which is 0.05. And as we saw in previous lessons, if your p-value is greater than alpha, that means we fail to reject the null hypothesis. And as a consequence of that, if we fail to reject the null hypothesis, then number 13, what can we conclude about the alternative hypothesis? The data does not support the alternative hypothesis. And then finally, number 14, state a conclusion in context. Hint, provide the significance level. Write what you can conclude about the alternative hypothesis and put this information in the context of the psychological treatment. So this is also similar to another example we saw at the previous lesson. We can say at the 5% level of significance, if we go back to what we were asked about, we were trying to confirm that the counseling sessions reduce anxiety. Since we did not reject the null hypothesis, it seems like the mean of differences in test scores is 0, which seems like there is no difference. So, at the 5% level of significance, we cannot conclude with this data that counseling helps to reduce anxiety.